Alright, time for lesson 1 of 2, where we are now in lesson 2.2 talking about similarity, and we're going to learn what similarity is with scale factors. There is a theme to why you have two of the same shape but different sizes. So, with our standard, we're going to use the ratio of a scale factor to illustrate the concept of a dilation. Now, actually, I have used the term for dilation in class before, but we haven't actually studied that. Dilation is a type of transformation, but it's where you produce the same shape as a preimage, only with a different size. So a dilation, as I have, it shrinks or it stretches the original figure. And there is a reason why I have these fit in here. A dilation can actually, you'll see that I have the lines which actually are tangent to or just grace the edges of these. If let's say they were like diamonds, they're kind of just grasping the edges, but yeah, you can see they are the same shape, just different sizes. And as the shapes will get smaller and smaller as they get closer to this point O, which could be like a radius. So, okay. Now, with this lesson, since we're going to be talking about similarity, similar types of shapes have something called a scale factor that they have in common. That's the ratio which compares two corresponding sides of similar figures. So if we have a length of 12 here and a length of 18 for corresponding sides, if we wanted to find out what the scale factor is, normally you'll go small to big. So if you want to write, let me see, small to big. So corresponding sides, let's say we put it, I'm going to write it as a fraction. 12 over 18. Now we are going to do some reducing fractions in this lesson. That's something that we're going to get some good practice on. So actually, both of these are divisible by 6. So then we'll reduce this to 2 over 3. And that's what the scale factor would be. Okay. Now when we have some figures, if you have three sides which are being compared, we'll get to this, but see how it says small to small? What I mean by that is, in order to properly associate these, it can get confusing, but what you want to do is compare, look at the three different lengths. We're looking at, let's say 40, a length of 40 for UV versus the smallest on the other triangle is 96. So I would try to use 40 over 96 to compare these, or maybe if I wanted to switch it up, I could use the next comes 60 with 144, and even further from that, we could also say 65 compared with 156. So that's what I mean when I say medium to medium or large to large. Alright. Now, so back. Give me a second. Alright. So, now we want to see if these polygons are similar. So in this first example, what we're going to do is actually compare, and again, I want to start with the small figure, or the smaller figure, and then work our way to the large one, even though it's not much larger. So let's say, and actually because this one has decimals, we're actually going to work with decimals as well. Okay, so if we have, let's say I pick 20 and its corresponding side of 22. 20 divided by 22, if we're looking for the scale factor, that would be, let me see, if I use a calculator, we can do that for now since we do have those decimals. That would be 0.9090. Let's just say that for now. Okay, make a note of that because we're going to check another set. Now let's try 27.1 and 20.3. So next we'll try the smaller 20.3 divided by 27.1. Now, if these are similar, that should give us the same scale factor. Take 20.3 divided by 27.1, and we come up with 0.74907, and so on. Well, since these numbers are different, these two figures are not similar. Okay, so we could say not similar. For those of you looking for a symbol to represent that, the symbol for similar is a little tilde. Now, if you're trying to say not similar, you would have your tilde, but then with a little line through it, and that represents that these figures are not similar. Okay. Let's try number 2. Now, you'll notice that we moved on. We didn't prove that every different side is not similar. Again, in order to disprove something, you just have to make sure that one part disagrees with something else claimed. So we did that in the last problem. Now here we look at the two comparisons. Let's start with 12 and 18. So I'll say scale factor would be 12 on top, 18 in the bottom. If you recall, 12 divided by 18 reduces to both divisible by 6, and we get 2 over 3. Okay, make a note of that. Now, if we compare a couple other sides, let's say 16 and 24. So if we take 16 divided by 24, both of these are divisible. If we're reducing, both are divisible by 8, so we can reduce the fractions to 2 over 24 divided by 8 is 3. Okay, so far they agree. Just to be certain, let's check the last set of sides. Now, something that I might do, 5.4 divided by 8.1. If we make both of these into whole numbers, we can just take the decimal and move it back, well, move it forward to the right one. So we're actually looking at 54 over 81. Now, I know that this could take a while to figure out, but both are divisible by 9, and if I'm being entirely honest, well, you know, if you want to reduce it a little bit at a time, we can do that. So let's say if we divide both by 9. 54 divided by 9 is 6. 81 divided by 9 is 9. And then 6 and 9 still share factors, so we could divide both by 3. And we get 2/3. So you'll see all three of these match, and that's what we're looking for if you're trying to confirm that polygons are similar. So you could say maybe yes, and you could say similar. That's fine. We don't have any letters, so we'll just have to say that they're similar. Alright, next, number 3. Using the scale factor, we're going to compare, well, it's always good. Let's start with the top, 6 and 12. So for the scale factor, 6 divided by 12, 6 goes into both of those, so that reduces to 1 over 2. Let's check the next part. say 7 and 14. Now, some of you may already know. You think, okay, well, I know my factors. If you do, fantastic. But if we're checking as a group, 7 divided by 14, again, 7 is the greatest factor in both of those. So again, this one reduces to 1 over 2. And we can confirm, based on the two scale factors and repeating side lengths, that yes, these are similar. Alright, but now I do want to say in the process, and you guys should know this by now, you can't just say, yeah, they look like, I don't know. I mean, I'm not just going to accept an answer of yes. Oh, yeah, let me go back. I think this was the one we were on, yeah. So please make sure you confirm with mathematical proof. Okay. Now for number 4, this is a little bit different. This one says the polygons in each pair are similar. That's given up right off the bat. That's good because now we don't have to check each different part for a scale factor. We need to find the scale factor though. So we're going to compare smaller to larger figures. So all we have to do is compare two sides. It doesn't matter which two, but let's say we take 35 and 21, or for the scale factor, got to do the 21 over 35. Okay. You're going to learn that this is a great lesson to know your factors. 21 and 35 are both divisible by 7. So when we reduce that, we would get 3 over 5. So there's the scale factor for number 4. You could say 3:5 as well, that's okay, but we're going to be, I like working with the fraction, and I want you guys to feel more confident working with them, so let's stick with it that way. Not to mention, if we had written it as 21 to 35, it still might get confusing. We're more familiar with reducing fractions. Okay. Number 5, same approach. These are already similar. We just need to find the scale factor. So if we compare, it doesn't matter. You could look at 35 and 42, or we could look at 25 and 30. Let's go with those. So checking out the bottom, if we take, setting it up, the scale factor is 25 on top over 30 in the bottom. Both of these end in 0 or 5, so they're both divisible by 5. Now when we actually check this out and simplify to find this, the scale factor comes out to be 5 over 6. That's the ratio between these two figures. And something interesting you could think about, if you're ever on a computer and maybe you're trying to resize, if you're in a program and maybe you're trying to resize something, you might say, I want my figure to be 70% height and 70% width. Well, then the program is going to readjust it. Now, this isn't exactly 70%. 5 over 6, gosh, I don't know. I think that's like 88% maybe. But then it would look more like the smaller figure. But people use scaling every day with even just software programs. So, all right, number 6, moving along. This is a new type of problem, but again, this says the polygons are similar. So we just need to find the missing side length. Now, what we're getting into is working with a proportion. Let's say we call this side x, because we're so familiar with working with x. We're going to set these up so we have, if you want to say 16 over x, comparing corresponding sides, that's going to be equal to, now we're going to go back to the large and we'll say 24, the smaller figure, so 24 to 30, Okay, and I am getting a little bit ahead of myself, so bear with me. You could do it that way, but what I want you to practice, just to kind of make it a little easier on yourself, first let's erase that 16 over x part. Let's write the scale factor. Let's see what that is, because we want to figure that out. 24 divided by 30 reduces by a factor of 6 in top and bottom. 24 divided by 6 is 4, and 30 divided by 6 is 5. So the scale factor is 4 over 5. Next, let's say we take 4 over 5, and we're going to set it equal to, actually, if we try this, now we can bring in our 16 over x equals 4 over 5. Alright, now what we want to do is cross multiply, because we're going to set a proportion. So we have 4x equals 16 times 5, that's 50 plus 30. So we have 4x equals 80. Then if we divide both sides by 4, we get that x equals 20. Okay. And that missing figure there is 20. Okay. But the style that I want to go through with you before we do move on to the next one, first we're going to take a look at what is the scale factor. Then, once we find that scale factor, we're going to apply it to the ratio of one side to the missing side length and set it equal so we can create a proportion. So that's step 2 there, and we can solve. Alright, so for number 7, looking at this, first we're going to compare 12 and 15. So we want to find the scale factor. If we take 12 divided by 15, both of those, well, you could either look at what's the difference between them, or, both of those numbers are divisible by 3. So if we divide both by 3, we would have a reduced fraction of 4 over 5. I think we had that in the last problem. But, okay, so now we're going to incorporate the question mark and its corresponding side of 30, a length of 30 units. So, we could say, again, if you want, you could use x, you could use a, but whatever, so that we could set up a proportion. So let's say x over 30 equals, just to make sure, the 12 is in the smaller figure, so we'll put 12 over 15. Okay. Oh, I'm sorry, not 12 over 15. 4 over 5. Because we did reduce that. Okay, so x over 30 equals 4 over 5. And then when we, once again, cross multiply, 5x, and then that's going to be 120. I like to put the x term on the left. I like to keep the variable that side. And that's equal to 120. So there's our equation. Short and sweet. And if we solve for x, get that x is 24. There we have the length of each mysterious side here, 24 units. Okay. Next, in example 8, we are, again, well, this is really no change from what we just did, because now we need to solve for x, but it does say the polygons are similar. Awesome, that's our best friend. It already tells us they're similar. So we can start looking for that first piece, the scale factor. Okay, well, looking at this, because the top side is 2x plus 3, we can't compare the 2x plus 3 and the 25 yet. So we'll focus on the bottom sides, the 21 and the 35. So let's take 21 divided by 35. And again, if you know your football scores, 21 divided by 7, both of these are divisible by 7. So would be 3, and 35 divided by 7 is 5. So there's our scale factor. Now, going back to small to big, if you really wanted to, you could put an S and a B in here, or S and maybe you like clothing sizes, so S for small, L for large. It's up to you. But we're going to take 2x, let's see, make this step 2. 2x plus 3, since that's from the small, over 25. That's going to be equal to the smaller value, 3 over 5. Okay. Now, when we cross multiply, this time what I'm going to do is I'm actually going to distribute in the process. So we'll take the 5 times the 2x, and we'll come up with, sorry, I'm running out of space, but actually I'll use the left-hand side. 5 times 2x is 10x, and then 5 times 3 is plus 15. That is equal to 3 times 25, which is 75. Okay, solving here, if we subtract both sides by 15, we have 10x equals 60. Then we divide both sides by 10. X equals 6. And we found the value of x. Yay. Okay. Number 9. Again, solving for x. Polygons are similar. So, let's first, again, step 1 is what? Find that scale factor. Okay. So, we're going to go small to big. That's always helpful. So, we're going to write what on top? 24. And that means that's corresponding with 40. So, if these are reduced, 24 and 40. For example, if you don't reduce it completely the first time, that's okay. If you know, let's say that like 24 and 40 are both divisible by, I don't know, 4. Let's just say that. 24 and 40, 24 divided by 4 is 6, and 40 divided by 4 is 10. Now, if you see 6 and 10 are still something you can reduce, then if we divide those both by 2, we get 3 over 5. Okay, so there's the scale factor. Now we have, I'm just going to label this, so we have small and large. Okay. Then I'm going to take, in step 2, setting up the actual proportion. And if you wanted to put what that represents, you could write proportion. That's a good way just to make a note. So we're going to incorporate the scale factor in. So we have 18 over 5x. That way we're going small to big, or small to large. And that's equal to 3 over 5. Okay. So if we cross multiply, we have 15x equals 18 times 5 would be, I believe that's 90. Yes, okay. So, and I'm thinking 5 times 10 is 50, 8 times 5 is 40, so 50 and 40 is 90. Now, solving for x here, if we divide both sides by 15, we come out with x equals 15. If you're thinking about that, 15 goes into 90. Well, I know 15 goes into 30 twice, and 30 goes into 90 3 times. So if you multiply those, x equals 6. And actually, that would come out to be our answer. Okay. Bear with me. I'm waiting for the technology. Alright. So, now, a little change of pace. This says that the polygons in the pair are similar. So when we set this up, we want to find the same missing side because it says the scale factor from A to B. That's the part we want to pay attention to. So that means we're going to set A looks like the smaller one anyway. So let's say A over B equals A over B. Okay? Something like that. Well, I'm going to put X. We could use question mark, but let's say, or, I don't know, maybe you want to use length A. I think I'm going to stick with X for now. So we'll use X over, the length of B is 15, and that's equal to 2 over 5. So, again, when we get to this step, we want to cross multiply 5 times x, which is 5x, and 15 times 2, so that's equal to 30. Short and sweet. So if we divide by 5, we get that x is 6. And we have the length of that part there, 6. Okay, number 11. Same example, just a different type. So, going from A to B as it reads, that scale factor is 1 to 6. So, let's, again, I like to use X. You can use whatever letter you want. You can use A. But if we say, for this, X over length of 18, it's going to be equal to 1 over 6. Cross multiplying, we get that 6x equals 18 times 1, 18. Go ahead and solve. X equals 3. Another problem in the books. Couple more, almost done. Okay, number 12. This time it gets a little bit, I mean, we instead of just playing one term, now we have a binomial in part B. So, from scale factor, the scale factor from A to B is 2 to 3. So, we can set this up where we have 12 from part A divided by 3x minus 9, and that's equal to 2 over 3. So what do we want to do? Cross multiply, or you could say you distribute as you go. Either way, we get, I'm going to kind of skip a step if you're thinking about it that way. 6x minus 2 times 9 is 18, and that's equal to 36. Okay, so there's our setup problem. Now, if we add 18 to both sides, get 6x equals 54. And if we divide both sides by 6, we'll get that x equals, and that would be 9. Okay. And since this one, if we look back at the directions, all it says is to solve for x. So, we're good to go. Okay. And the last one. Give me a second. Sorry, my screen is working up on me. Okay, number 13. Scale factor. We've got a scale factor from A to B, which is 1, 2, 3. So, starting with A, we're going to put 5 over B. The expression is x plus 6. That's equal to what? 1 over 3. Okay. Now when we cross multiply, 1 times anything is that same thing. So we have x plus 6 equals 5 times 3 equals 15. And last step of this lesson, subtract 6. So we get x equals 9. Cool. And we're done. Alright. On with the assignment. Again, make notes if you would like. You may ask questions on the page, but good luck.